So on this one, we're going to be looking to find a vertical asymptote, and a vertical asymptote can occur when the denominator equals 0. But this is kind of tricky because there is actually embedded denominators that we're not seeing. So let's first, I'm going to change the form of this. So we would have, instead of cotangent, that's the same thing as 1 over tangent, but tangent is, remember, sine divided by cosine, so that would be cosine over sine, and then I'm dividing by cosine x. Remember, that's cosine over 1, so I can flip the second fraction and multiply. So I would get cosine x over sine x, and then I'd flip this and multiply, so that would be 1 over cosine x, so that cancels out with that. However, this is the same thing as the original right here. So I do have a denominator that's cosine, right, because that's in the denominator, even though it cancels out over here. So this function behaves like this function. However, we're not allowed to plug in anything that makes cosine 0. So that's where we can check for our vertical asymptotes, where whatever x value makes cosine 0. But also, with a sine value of 0, I mean, sine is still in the denominator. So we have to check and make sure that we look for the values, the x values that make sine 0 as well. And then we'll continue on from there. So I'm going to do this just from, let's just say 0, x, and then I'm not going to include 2 pi. Well, 2 pi, 0 to 2 pi. That's what I'm going to consider this for. And then, because there's an infinite number of asymptotes or holes or whatever, just because this repeats over and over and over again. So, what's next? Finding where the denominators equal 0. So that first one is obvious for cosine. When does cosine equal 0? And from the unit circle, cosine is the x-coordinate, so that would be at pi over 2, and also 3 pi over 2. So x equals pi over 2, and 3 pi over 2. So I'll eventually have to evaluate limits. I don't know if there's a vertical asymptote here or not. But then, let's see, and then sine, the second case, sine. When does sine equal 0? Why am I checking this again? It's because I possibly have a vertical asymptote when the denominators equal 0. When stuff cancels out, I usually just have a hole, but we're still going to take the limits as x approaches these values from the left and the right, and we'll see what happens. So for sine x, when does that equal 0? Well, that's just at 0 and 2 pi. X equals 0 and 2 pi. And pi, right? 0 and pi and 2 pi. So that's 3 values. 0, pi, and 2 pi. 2 pi is a repeat, though, because it's in the same spot. But there we go. Now, I got to see if they're actually vertical asymptotes or if they're just holes. I suppose we could graph this and look, but I want to do this algebraically. So, let's think. First thing I'm going to do is I'm going to just take the limit as x approaches pi over 2 from either side. And I'm going to try and evaluate the two-sided limit. I don't think anything weird will happen, but we'll see. So, limit as x approaches pi over 2. And we're going to do a two-sided limit, and I'm taking it of cotangent x divided by cosine of x. So let's see. As we approach pi over 2, well, again, I'm going to change this into something that I'm more familiar with. Oh, sorry, it should be cosine x over sine x. Okay, so this cancels out. So there's definitely not, I don't think there is an asymptote then, right? Because as, well, maybe, let's see. The only way we would get an asymptote is if this approaches infinity or negative infinity. And let me just, before we do this, let me show you why. If I have pi over 2, say this is pi over 2, and I take the limit from both sides, and I get positive infinity, that means as my function approaches pi over 2, I go up to positive infinity. If it was negative infinity, say from the left side, or sorry, the right side, then as I approach pi over 2 from the right side, I would go to negative infinity. That would mean this is an asymptote, only if it's going to infinity or negative infinity. If it's going to some number, undo, whoops. If it's going to some number, like say this was, instead of infinity, this was 3, 1, 2, 3. Then as we approach from the left side, we're approaching 3, and maybe from the right side we're approaching 3. There would just be a hole there. So there is no asymptote, it's just a hole. So let's see what happens. If we get infinities, then there's an asymptote. If we don't, then there's not. That's pretty straightforward. So if we take the sine of pi over 2, I'm just using direct substitution. Sine of pi over 2, that's 1. So this actually goes to 1. Even though cosine, you're not allowed to plug in pi over 2, sine goes to 1. And that means, well, for our graph, for pi over 2, we're heading up towards 1. I don't know if it's going like that or like that, but we know that there's not an asymptote there. If we went from the other side, from both sides actually, right? Because we approach, sine approaches 1, positive 1 from the left side and the right side of pi over 2. So that it's 1 both ways. So there's no asymptote there. And we can actually think about it with 3 pi over 2. It just approaches negative 1 because the same thing happens. So again, no asymptote there. So we don't have to describe any behavior on the left and right. Here though, let's see what happens for this stuff. So I'll do that in green, and I'll do it right here. Limit as x approaches 0. And this will be, I suppose, from, we'll do from the, well, I'm thinking about it in my head. Sine is negative if I approach from the left side. Sine is positive if I approach from the right side. So I might have to do 2 cases. So this will be from the left side. And I take the limit of my original function, which would be, I'm just going to write down this stuff all over again. So again, those cancel out. And sine of 0 is 0. So really, I'm getting 1 over sine of x. And this is going to 0. So that means the whole entire fraction is going to infinity. However, we know that from the left side, if we approach sine of x, if we approach 0 on the left side, sine will be negative. I just got done saying that. So that means this is approaching 0, but from the negative side. So that means this whole entire thing approaches negative infinity. It's similar. You can relate it to the limit as x approaches 0 from the left of 1 over x, because that's also negative infinity. This is the same thing for the right side of 0, except x approaching 0. It's happening, and it's going to positive infinity because sine is positive on the right side of 0. So this goes to 0. The whole entire thing goes to infinity because this is positive. So then that's positive infinity. So we definitely have an asymptote now. Definitely at 0. So there is an asymptote on the left side. So it's saying describe the behavior on each side. And I think it'll happen actually in every case. Maybe, oh, maybe not. In the odd pi cases, well, we'll take a look at that in a minute. So to describe this, we could say on the left side of 0, left of 0, we go to negative infinity. Right of 0, we go to positive infinity. And there's a vertical asymptote at x equals 0. Right? Maybe? Yes. And then there's also, the same things will happen at pi and 2 pi, except when if I draw the unit circle, if I'm approaching pi from the right side, this time, wait a minute, approaching pi from the right side, that means I'm plugging in things that are bigger than pi. Remember, all this stuff is bigger than pi. So if I'm approaching pi from the right side, I get a negative sign value. If I approach pi from something that's smaller than pi, from the left side, I get a positive value. So it's actually backwards for pi. And then switch back again, because we're back over there, for 2 pi. So it actually, left of 0, that's right of 0, okay. And then in the other case, when you have k pi, where k is odd, then it would be this but backwards. So on the left of k pi, you would have a negative. Oh, sorry, a positive infinity. And then right of k pi, that would be a negative infinity. What is k? K is just a number. Remember, this goes on. I was only solving it for this interval, but it goes on from negative infinity to positive infinity, so we have to have a way to describe it. But I know that sign is 0 at 0, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. But I also know that odd values of pi are here, even values of pi are here. So if k is odd, we switch around the stuff. If k is even, we write it like that. I have no idea if that's going to make sense to you, but good luck.